So last time we worked on the Raytracer, right? And this is what we managed to produce. Oh, sorry, echo. Right, there we go. So yeah, to come back, so we managed to create the Raytracer, and last time we implemented refractions and reflections. Right, that was pretty cool. However, if I comment this out again. And then same for this. Comment this out. And then we don't need this transform. If I re-enable this, right, and then say about 500, right? Or no, 500. We can still see that's incredibly slow. Oh, okay. Yeah, oh, okay, right. The camera is way too close. Oops. Right, I need to put the camera a bit back so you can see what's going on. Right. So you can see this mess of a car, and it renders, right? Let me put the refractive index off, so it's just reflections. Sup, Beryl? Welcome to the stream. Right. And I don't think I have a light. Oh yeah, I need a light a bit closer to my camera. Right, so yeah, I was just showing off the Raytracer, what we managed to do last time. What was refractions, so we can actually look through objects. However, what I wanted to show was the fact that I'm good, thank you. Just a bit tired, I may have gone to bed a bit too late. But yeah, we can render now a bunch of objects. However, what I found out, what I completely forgot, is the following. So if we look at the Raytracer, and then at the light calculations, the apply shading, we can still see that we're going over all point lights and then going over all models instead of actually using the BVH. So I'm wondering, right, if we turn off the lights here, would the scene magically render about 1,000,000 times faster? It would, okay. That's way faster. Okay. So changing this to be using the BVH shouldn't be too hard. Because I completely forgot about that, right? So it now goes in the Raytracer. It gets the closest model using the BVH, but we completely skip the traversal for the lights through the scene BVH that we created. But anyway, I'm going to be right back because I'm really thirsty, so I'm going to go grab something to drink from the fridge. I'll be right back, guys. Throw it away barrel, right? So yeah, coming back to the weekend stuff, right? Yeah, did you do anything cool this weekend, man? Or just chilling at home, like you probably should at the during a pandemic? Okay. So the light traverse is going to be very similar to the regular traverse, but we're going to need some extra information. This can just be a bool, traverse BVH, entity models, node, ray, but we don't need the Oh, you do? Okay, cool. Which one was it? Did you get a different one, or? Yeah, so which one are you getting now, Barrow? Ah, okay. Cool. Right. So then we want this. So return info. No, this will just be a bool. Bool hit is traverse BVH with early out. And we don't need these values. Let me just say return. I think we could just return hits, actually. We don't need the temporary one. Right, sure. Or we could just do this, right? And we don't need this one. And then for the subdivide here, no, not we want to get this code, and then copy this in here, and then make some slight changes. So if we don't hit this, return false. Right. So if we hit, we just return true, because we don't care if it's closer or not. And the oh no, we do need one thing actually. We need the distance to the light, right? Now this would be light traverse. Yeah, right. So we're gonna need the light position as well. But yeah, Beryl, which one are you getting? The GPU at 1060 Super. Oh, that's not bad. That's pretty cool. That's a pretty nice GPU. I mean, you were getting a 580 before, right? I think this would be actually a upgrade, or at least very similar in performance. And then I need to change this here as well. And then we need to pass in light pulse. Yeah, but I think it's definitely a better option. It's quite a newer GPU, so I think it's a pretty good choice. Right, so if hit. Oh, but we don't get the distance. No, actually, we don't care about that. So if hit, return true. Right. And then return, if not, return false. Right. So if we hit anything, just return. Um, then in here, right, you want to do traverse BVH with early out. And the only thing I think, so we don't need these, but we did need light distance. Oh. Huh, that's nice. That's a pretty decent saving. Like, for sure. Um, yeah, okay. But yeah, no, that's actually really nice, that savings. I mean, saving money in general is always good, I think. Right, and now replace this. Yeah. Now, I'm still looking to upgrade my GPU as well in the future, but yeah, it's just not really interesting at the moment. Because I would want either a 3080 or a 3070, but they're just not available at all. Right, I think this should be good. So this is basically the same intersection, but now we just do some slight changes to it. So we basically just skip. We don't really care about distances. We just care if we hit something. So if left or right, then just return true. Right. And the only thing I needed to check was... No, that's actually fine. Again, this is good. And then in here, in the apply shading, we would say, no, don't do this. Yeah, we would say light visible. Light visible is equal to what am I doing out here? So it's a light traverse. Yeah, okay. So light visible is equal to traverse. So this would be m dot active scene dot scene BVH dot light traverse, and this would be light dot position scene. Sorry, m dot active scene dot models ray. Oh wait, do we have the light position twice in here? Oh, we do. Okay, whoops. Yeah, so we don't need this in here anymore. Unload time. Right. And then pass this one in. Right. And yeah, because if it returns true, the light isn't actually visible. It means we intersect something, right? I think they should actually provide us with the result as before, but now it should be faster, way faster. I don't think we have lights. I don't think we have lights. No, I do have lights. Huh. That's a shame. I really hope that this would magically work and my experience with BVHs would actually solve this problem immediately. But it clearly doesn't. What is a shame. Right, just to be sure, I could just test if the negation here makes any difference. I don't think it should, but... Oh, okay, now the shading is there, cool. So it was actually correct before, sure. Because basically it was doing the inverse, so it would apply shading if it wasn't correct, and if not right, whatever. But now at least it is using the BVH, unlike before. Let me just double check this code as well. Yeah, sure, that's correct. Okay. So next up, what I wanted to do is see if I could visualize the bounding volume hierarchy. What I've tried before, but I think I realized what the problem was. Yeah, sure. So I think the issue is that everything was in local space. When I could put to world space, we were losing we were getting some issues with that. But the scene BVH, in fact, is in world space. So I think we can actually really easily draw this scene BVH. So let's create a small function that would be void draw BVH. This would take in a const glm met for reference projection and a const glm mod for reference view matrix, right? I don't think we need anything else. So we create this implementation. And then in here, just before I render, well, I think, yeah, we draw the pixel buffer here. I think, yeah, so that's draw pixel buffer, okay. But I think before the update, we need to call it. So we would get m.testscene dot cbvh dot draw, and this would be m dot current camera dot get projection and m dot current camera dot get view, right? And this should call the this function. Sure. We would then have a GL begin, and we would need the OpenGL function, of course. Like include graphics, I think. Yeah, graphics, OpenGL, and glad. Right. And now then we should have the GL begin. Yeah. And this would be GL lines. And then we would need a GL end. Right. And then we would say, well, we want a for loop over m.nodes, right? Although no, we could actually do this for each. That's fine. So this is m.nodes, right? And this would be although an auto ref element, right? Or we could just say no. Oh no, we can't actually do this because this isn't there's a pointer, right? We can't do that actually. Never mind. So we do need a for each loop. For just a regular for loop, sorry. Right, so we need number of nodes and then get rid of this, right? So then have a BVH node pointer, current nodes, and that is equal to m.nodes dot y, right? Yeah, and this would be a const reference. Sure. Then we would say, well, GL line, so GL vertex 3f, right? And we would need some off here. So we would have a GLM vec4 position. So this would be left corner, and that's equal to current node dot bounce dot 0, and then 1.f, of course, and then 1.f, and then we would have a right corner, and this would be equal to bounce 1, right? And I just need to double check the order that we multiply this in. Right, come on. What's the order? Google, give me the answer. No, that's not helpful either. Can Wikipedia tell me this? Because it was something like, I think it's projection times view times model. Right, I think it's just, so left corner is equal to projection times view times left corner, I think. And then right corner is equal to projection times view times right corner. Right, and then we say glm vec3. Oh, that won't work. So we do left corner dot x, left corner dot y, and left corner dot z. And then a gl vertex 3f, and this would be right corner dot x, right corner dot y, and right corner dot z. Right. So now, if everything went well, we should have the projected vertices of the bounding volumes like diagonal lines, right? No. Okay. Oh, I think I still need to normalize them, but I'm not too sure about that. Right, let me see what kind of values we're getting here. Because they might simply just not be in view. Ooh, okay. I think we might have to normalize them. So LC divided by equal by LC dot W. And RC equals divide equal by RC dot W. Let's see what this does. These might be normalized now. Oh, there we go. That's doing something. That actually might be correct. This is, yeah, this is definitely modern art. No, but what we're trying to, the thing is kind of hard to verify without all the the boxes properly put in place. All right, I'm just trying to find an example of projection. Yeah, thanks, Jinx. Right. But at least we're getting them on screen, right? But the idea is that they're the diagonal lines of the nodes. So ideally they would encompass all objects, but it kind of looks wrong because like this is hard to judge, right? Because this is just a yeah, let's not talk about this. But we can see here, right? Here's a diagonal line, but this car wouldn't be encompassed by anything, so that would actually be wrong. But it might actually be wrong. So I'm just trying to find a simple example of the projection. Hmm. Because there are some, I found some really good examples on projection. Right, so it's m dot projection times view times model times local. Okay. But we don't have a... Right. So what if I do GLM inverse on these? Right, what happens if I do this? Huh. That's even more modern art. But this looks very, very old. Right, yeah, so it's just projection times view times model, and then times the position. But then I think we... So it should just be this, right? And then what if we don't normalize these? Or might just need to actually normalize them. Yeah, so these are completely out of bounds, right? I could do glm normalize. So what does this do? Yeah, so we can't see them either, right? So the dividing by L's by the W component does seem to be about correct. You know, I have a better idea. Instead of taking this corner, we could just do 0 plus current node dot yeah, so this would be that, and then rc dot x plus equals current node dot bounds dot 1 dot x, right? And now this would be a straight line on the x coordinate. Let's see what that does. So we should only see straight lines. Yeah, there we go. But we can clearly see that there's something wrong with this. Because the lines are, like this car, for example, right? There's no line underneath it. Although, no, that might actually be fine. Think about it. Because, right, it might... We can see all the... We need to zoom a bit more out, actually, to verify this. Because it might actually be correct what we're looking at. So let's verify this. Right, so this might be correct. This is the left corner, right? And this is the left corner of something. It might be that there is a node here, right? This might be correct. So, I was thinking, why don't we draw... Let's only actually draw the first node. That would actually help quite a bit. So this would be just 1. So what happens if I only do 1? So this would be the root node, right? What line would we get? Okay. So there's definitely something wrong, right? Because the root nodes is supposed to contain everything. But we can check as well that this is node 0, and these bounds are minus 6260, right? So that would be, like, because 0, 0 is in the center, right? So that would be a bigger stretch. But I think we can actually check that RC is negative and LC is negative. Okay. But we can work with this. So if we, what happens if we inverse these? Right, because what we're kind of looking for is the line to be under everything, right? And if that's the case, we know that the projection happens correctly. And then we can actually draw all 8 points. But we will get there later once the first part is working correctly. Okay, no, I don't want to debug this. Right, so this is definitely wrong, because this line is now very, very small. Because the line should stretch from basically here to here-ish, right? Not like this part. So maybe it's not the inverse view. I'm just playing around with these values because I keep messing up projection majorly. No? Okay. I mean, luckily aren't that many options, so we will get it at one point. So what if I don't divide by the W components? Right, because I think we might be projecting it. Yeah, we need to um, cast it to normalize device coordinates, right? So I think we might be definitely doing something wrong. So it's a 3D, project 3D point to normalized device coordinates. Right, let's Google that and see if that helps. All right. Mm-hmm. So this is the world. Yeah. Okay. Mm-hmm. Mm-hmm. I really suck at this. Right. So this is the camera. Compute pixel coordinates. Right. So world to camera. Okay. So it's camera to world dot inverse. Okay. Yeah. But this isn't quite what it looks like. Hmm. No. Okay. So let me pop open the document I've opened. Right. So if we go to display capture. Right. So this is the and let me close the ray tracer. Okay. Right. So we have this document, right? So the following function converts a point from 3D world coordinates to 2D pixel coordinates. This implementation is quite naive, but we didn't write it for efficiency. We wrote it so that every step is clearly visible and contained with a single function, right? So this is compute pixel coordinates. Okay. So this is the pixel world coordinate. This is camera to world, canvas width, canvas height, image width, image. Yeah. Yeah. So we'd have the world to camera space. Okay, sure. So the camera to world is the following. Um, so I think that would be the inverse projection matrix. Let me double check. So it'd have camera or camera to world, right? That would be, so world to camera would be camera to world inverse. Okay. Sure. So we would take the inverse here. Multiply, yeah, p world, p camera. Okay. Right. So I'm just going to write this along as we go. So it would say that, well, we have these are the 2 points, right? Then we say, well, that is times, but we don't have a view. So that's kind of bothering me about this implementation, is that it doesn't take the view matrix into account at all. And that really, really bothers me. Yeah, because it's almost looked like an orthographic matrix. Yeah. Okay. Okay, no, I found I think I found a better source. Okay, so I found the learn OpenGL source. So we have the following. We have the view matrix, and this would be just identity by default, but we have this in the camera. And then we translate it a bit, but that's fine. We can figure this out. And then with the projection, what is this GLM perspective? Yeah. And then the position here is projection times view times model times the position here. But I think this is the local, and the model would bring it to world, right? But we already have it in world space. But that's fine. Yeah. So yeah, this is a good example, right? So model, this is just rotating it. Sorry. Okay. Yeah. So this is the actual function, right? vclip is m.projection times m.view times model times local. Right, in the predictor, and OpenGL will automatically perform perspective division and clipping. Okay. Perspective division, okay. Um, right, so I think it's basically we passed in this right, but then we're kind of missing the last step here. What would be the final transform? I think that would be the viewport transform. Okay. Hmm. But it open. Hello, Sefin. No, this isn't AC. You were working, so I decided to do something else. I can't kill people alone, man. I need a companion in for Daisy. Right. Yeah, but I have to go to work soon as well. So that may mean that we need some other things as well. Okay. I can't just skip work every time, Scythian. I can't skip work in general. I need the money, okay? Right. So we have the I don't have Rona. Right. Okay. So we have the following, right? So this is these are now the projected points, right? Then we need to do the following operations on it. So we have a GLM vec2 screen, and this can be just hard coded for now by 800, right? Oh, Scythian. Thanks for the chair, Scythian, for the 1 bit. But yeah. Where was that? Right. So we have the screen position, and then we say pscreen.x. So screen. Scythian, you're a madman. You know that? So the peak camera now is the... Oh yeah, that's going to be awesome to spam. Yeah, that might actually get really annoying. But we'll see, we'll see. Okay, maybe I need to put a halt on this Siphon so you can't spam every 3 seconds. Siphon, why are you doing this to me? Siphon. So, Jinx, you want to know the worst part? So I think 1 bit is equal to what, 1 cent? So that means that he can spend this for about 1 cent every time. So I don't know. I think I can set a limit on this. But... yeah, I can, but you know, it's also kind of funny seeing Serafian spam this. You know, I'm just kind of curious at this point how long Scythian can keep this up. Because, I mean, he must get bored at some point, right? And I don't really know how I can turn up the oh yeah, I can increase the number of bits. I found it, Scythian. Yeah, we can uh right, we can increase it. Error. Okay, never mind. Can I increased it, Scythian? You can't do it anymore. You now have to do 10 bits. I commented the spam. I mean 10 bits is 10 cents, but you know. Right. Right. So coming back to what we were actually trying to do is to do the projection. So the peak camera.x divided by the z, right? And I think this is just the, what is the peak camera? P world. Right, P world, peak camera. So I think peak camera is the actual point that we just calculated according to this. Sure. So would say screen X is equal to LC dot X divided by LC or minus LC dot Z, and screen dot Y is equal to LC dot X sorry, Y divided by minus LC dot Z. Type in. You can't do that. Right. All right. Let me turn on my screen again. Right. So this is the what they have, the compute pixel coordinates. So they have this vector 3 peak camera. So they have an example here, right? So the peak camera is right. So it's P world that they pass in. I mean, James, at least it's not. Sapien, don't make me put up the bits again so you can stop the spam. Damn it, Sapien. Right. So peak camera, and that's the. Is that just the actual? Wait, peak camera is actually an empty variable here, right? Oh, it stores it in peak camera. What is the... Wait, is it? So world camera multiply vector matrices, and that's the world times peak camera. But where does peak camera get set? God, that Safi, stop it! I don't focus anymore, Jinx. I'm getting distracted by the pings every 3 seconds. You figured out the minimum immediately. Safian, stop. How much have you even been gifting at this point? That works, thank you, Jinx. Okay, so Safian has donated currently €3.16. That spam was worth that much. I mean, I'm happy with it, but holy shit, Safian, that was a lot of spam. Thank you, Safian. No, I'm afraid so either. But we can see in 10 minutes. Oh shit, I don't want to share Discord. Ah! Right, so, sorry, coming back to this. Yeah, his rage will be worse, for sure. But what I don't get, right, with this, right? So they have the peak camera here, but this is uninitialized. Then they say, well, the camera to world inverse, yeah, sure, that's fine. But then they say, well, world to camera multiply with P world, okay, and store that in P camera, I guess. Yeah, sure. So that's the transform point actually. Okay, no, I think that's correct. Then what we're doing. So then we, yeah, sure. But then we're going to need this twice because we're going to need it for two vertices, right? And that would be, this would be RC. Okay. So then we got the screen position. And then we need, okay. So we need two GLM, and this would be NDC. And then we need another one. Right. Then this is equal to the following. Right. And this is NDC, right? So this is screen.x. And this is 800.f. And this is 800.f, yeah. And this is screen.y divided by plus 800.f divided by 2 divided by 800.f. Okay. And this would be needing to be done twice. And this is then screen, right, like this, right? And then we would need P raster, right? So what if we just do GL vertex to F, and then we say this is NDC dot X and NDC dot Y, right? Right, what happens now? Do we now magically get the line correctly? Right. So this is exactly not as it should be. We have a diagonal line. So why is it diagonal? How did we manage to do that? That's very interesting. They need the inverse here. Ah, ships, I'm almost out of energy. No, how did the line go diagonal? Because this is like, okay, so look at this, right? This is a straight line. Yeah, right. So we have minus 60 to wait, what? Oh, right. To like wait a second. This x is 6. Oh. Oh, wait a second. This should be equal, right? So we had all this magical functioning, but what I was doing was actually correct before. And we don't need. So I think we multiplied by the inverse, right? Let's try that. I think I made a mistake here. I was only LC divided equal by LC dot Z, and RC divided equal RC dot Z. Sorry, W. I think this might actually be correct what we're doing. So then we have a GL vertex 3F LC dot X, LC dot Y, and LC dot Z. And then we do the same thing for RC. So do we now have the line correctly? Because this might actually be fine. No, okay, I don't think we should actually multiply by the inverse. My bad. Because everything is already in world space. Okay, there we go. This looks more like the correct line. Maybe. Yeah, no, that might actually be fun because it takes the center points of everything. Okay. So what if I then actually try to draw all 8 points? Let's give that a shot, right? And what if it's just the inverse of the projection? What happens then? Just double checking. No, okay, that's definitely wrong. It might be the inverse of the view, but I doubt it as well. But I just want to try all the possibilities. No, okay, I don't know now where it now went. Now went somewhere in space. Right. So we need to do a bit of code. So it would be yeah, let's define all the points. So we would need points. So we have a GLM. No, I think we can actually take the point thing from here. As from the scene BVH. Oh, it seems that Visual Studio has crashed again. So let's restart that real quick. Sorry about that. So we go to scene BVH and we have this magical function, right? That gets me all the corners. So then in the scene BVH here, I go down. Come on, Visual Studio. No, it actually crashed on my screen as well. Okay. And then we do the following, right? So we say this, and then it's current node.bounds. And then let's just replace all of these. I'm glad I did this before, because it's making my life much easier. Right, there we go, there we go, there we go. And then we need a for loop, another one. for E, and this is we can just use J here, and this would be 8. And then we say GLM vec3 P is equal to projection times view times corners.j. And this would be a GLM vec4, right? And with 1.f, because it's a point, right? And then we say P divided equal by P.w. Oh no, there should be a vec4. And then we say GL vertex vertex 3f, p.x, p.y, and p.z. Right, so now we should see all 8 corners, hopefully. No. Okay, that's wrong, for sure. How did I manage to do that? Because it was working before, right? That's very interesting. Because the first node is x, yeah, and this would be the z line. How is that suddenly breaking everything? Yeah, so I would like to... Yeah, no, this should be okay. This is literally what I just did. What? How did it break? By the way, Jinx, I think it's almost time that Scythian is released again. But how are we getting diagonal lines now? I mean, no, we shouldn't be able to get diagonal lines. So let's do this a bit different. Let's say we only have two, and it's this is commented out because we can't use them. And this would be 1, right? And this is the only difference here is the x coordinates. So let's see what happens now. Okay, so now this is fine. Okay, because I'm thinking with the GL lines, it might cause issues. Right? No, you know what the issue is? I think every line is based of 2 vertices, right? So we only have 8, so that would mean 4 lines would only be drawn. Good. Wait, Seppi, how is your badge changing every time? Oh, you're the bit leader. Okay. I mean, yeah, you're definitely the bit leader. Almighty bit leader. Well, what is your great plan for events, Siphon? So, no, you're not the bit king. You're the bit leader. I mean, you could be the bit king if you would like to, I guess. Um, right. So this would actually be fine. So we would need to increase this to 16. Oh, okay. Sorry, Siphon. I'm blind. Then I won't see it coming. So I think we need to duplicate corners. Okay, so this is going to be fun. Okay, what we can just do is say we Okay, we go from line to line. No, we can't do that. God knows, I can't just delete everything. Okay, no, we just need to define vertices, right? So this would be the bottom one. The bottom line. Then we need to define two vertices for the upper line. Okay. So that would be, this would be lower x. Then we want the other x one. So that would be this line. Well, let's comment this out, right? And this would still be the lower x, but then it would be on the different set, right? And this would be front, and this would be back set, right? Although I don't think we will be able to see it. And this would be 2 and 3, right? So then we want to do the same, but then we want to increase the y. So it would be 4, 5, 6, 7, and this would be still the same x, yeah. No, sorry, this is incorrect. This would be 1, 1, 1, 1, yeah. This would be zx, yeah, right. So this would be 0, 0, this would be 1, 1, and this would be, yeah. Sure. I think this is actually back set, and this is front set. Right, so this should draw 8 lines now. Sorry, 4 lines. Okay. Then let's get the y's in. Okay. So we would need this. So it would be 8, 9, 10, 11. And this would be x0. 0, yeah, because we're not changing anything on the x, and this would actually be 1, 1, 0, 0. And this would be 0, 1, 0, 1. And this would be these sets, yeah. So left, y, back, z, and this would be left, y, front, z. Then we copy this again. And then we say 12, 13, 14, 15. And this would be still the x like this, the y like this. No, sorry, this would be 0, 0 as well. And this would be 1, 1. Yeah, 0, 1, 0, 1, and then 0, 0. Yeah. Okay. So that's the upper ones. Yeah, I think we have all of them, actually. We have the x's, and we have the y's. No, but we don't have the z's, actually. Because now we just have, like, these lines of the cube and these lines, but we don't have these lines. So we need a bit more lines. So we need 4 more of these. Yeah. So this is 16, 17, 18, 90, 20, 21, 22, and 23. So this would be the same x, yeah, 0, 0. And this would be 0, 0, 0, and 1, 1. And this would be 0, 1, 0, 1. So this would be left Z. Yeah, sure. So left Z, but this would be on this x. And we can just say left x and left x. Yeah, sure. And this would be 0, 0 x, 1 1 x, and this would be no, sorry, this would still be 0 0, right? And then this, yeah. Oh, and 0 1, and I think the order really matters, but it does form seeing it. And then this would be the right x, and this would be 0 0 y, 1 1 y, and 0 1 z, and 0 1 z. This would be right z, right x. Right z, right x. Okay. And now we actually we have 24 corners, apparently, and then we would go 24. Yeah, it changes. Okay. So does this now magically draw my cube? I really hope so. It's close. We're still missing a line here. But it's definitely drawing something, right? That resembles a cube. But we're missing this line. So this would be... We're missing an x1. Oh, yeah, there we go. I spotted it. So this would be... Yeah, so these are the... No. Yeah. So these were the exact same, yeah. Wait, are these the 0011? No, okay. This should be... I should have the box. I think now we have the line. Yeah, there we go. So now the box is closed, right? I think this might actually be correct, looking at it. However, it's obviously not correct on the screen. But everything fits the box, if you can really call it that. I think it's just outside of the screen. So what happens if I move the camera further back? I don't think it will fix it, but we can check. Because this might be a bigger problem than anything else. Oh no, there we go. That's looking fine. So this actually looks good. Okay. This actually looks really, really solid. Okay. Huh. This looks like the box, right? And we can see all lines. And this clearly contains everything from the image. So what I wanted to do now was the following, right? So I can say we would really want to draw a certain depth of them. So instead, if I go to the CBVH and be like, well, no, I don't want to draw just one. I want to draw the number of nodes, right? So now we should be drawing all nodes. And this should look really, really horrendous. But this looks like it. This looks actually correct. This actually looks perfect. This looks great. That's perfect. And I think we can do GL color as well. GL color. I think we can do, we can set a color as well. Let me check again what the command was. I think we can increase the line width as well. Because there was definitely like a geocaller that we could do. I'm just trying to, I think it was like geocaller, right? Geocaller 3F. And what did we do? 1.f, 1.f, 1.f. Right, what happens then? Do we now, oh shit, that's byte still. Right. No, but I want to do 0, 0.f. Right. So this should give me a red line if everything goes well. There we go. This gives me now red lines. Cool. I think that's going to be a bit easier. And I think we can do as well GL line width. Let's put this to like 5.f, right? Do we now get thick lines? I hope we could do. Yeah, now we get much thicker lines. Okay, that's actually nice. Okay. So let's put this to 1.f, right? And we're clearly going to need to improve this code because although we can now visualize the BVH, it's kinda useless because the following reason, right? We can now see all the nodes, but it's kind of a massive cluster, right? It's really hard to see what's actually going on. So what I want to do is create an GUI layer that can visualize the at certain depths only, right? So we would need a we're going to need another function. So this would be a void traverse draw, and this would be just the const bvh node current node, and then we want a, yeah, I think just this, right? Oh, and a int draw draw depth. So this would be which depth we want to draw. No, and then we want a generate implementation. Okay. So then we do we say no. Where's the you'll begin thing, right? Yeah, it's here. So then we say I don't want to just do this. Yeah. So we say traverse draw, and this is m.nodes 0, right? Oh, and this would be we would need to pass another function in here, and this would be an int draw depth. And then in here we would need another int, and this would be int current depth. Because we need to, of course, know which depth we're in at the moment. And this would be then 0, and this would be draw depth. Right? And then we need to change this function as well to take it in. This would be int current depth. Right? And then we place all of this in. Yeah, no, this would just be we don't need this anymore. We can just do, oh, and this can be, should be a reference, right? Const ref. And this function is const as well, because this doesn't change anything. Okay. So then we say, yeah, current node, yeah, that's all fine. And then, oh, we don't pass in the projection in here, do we? No. We don't at the moment. We do need that. So we pass in those as well. All right, there we go. And that should be there. Okay. And then in here we would need to pass in those two variables as well. Yeah, so that would be projection and view. Right. What is wrong with this? Is it because it's not a const function? Right. Are you okay now? Oh, we didn't change this here, right? So int draw depth, right? And now this should be fine, yeah. And its reverse draw now goes there. Okay. So then we say so we only do this if current depth is equal to draw depth, then we want to do this, right? And we draw this, right? And else, no. So first we want a if current depth is greater than draw depth, then return, right? Because that means that we're never going to be drawing anything, so we don't need to traverse more nodes. It's not a big impact, but it doesn't matter that much. So then else we do traverse draw, and that is m dot. Oh, we need the termination as well. So if current node dot count does not equal 0, then we return as well, right? Because that's the termination. So this is termination if the node is a leaf, and this would be skip all further nodes if they are never going to be drawn. Okay, and this would be draw node, right? And then else, if that's not the case, we say traverse or draw traverse draw, and that would be traverse draw. So it would be m.nodes dot current nodes dot left comma projection view current depth +1 and draw depth, right? And then we do the same for this one, but then we say, well, +1. Yeah, sure, whatever, it's fine. And that should traverse it. So now we can say in the application, so this would be draw depth would be 0, right? So we can now say, hey, I want to draw the node 0. Right. And if I do the following, if I say I want to draw 1, can I do that as well? So now we should only draw the, yeah, we now draw these two nodes. Okay, that's actually awesome. Right. So then it's time to get another GUI thing in. But for that, we would need some scene information. Right. Sure, we can just pass it in the current scene. So let's go to GUI layers and then add class. And this would be the BVH layer. Although no, we could just put it in options, right? So the options layer, this would need another thing, right? So we want to do options layer, and this takes in a yesterday shared pointer of type RT scene, right? And a reference, and this would be a class scene forward declaration, right? This would be a current scene, and we would have this here. No, we could just pass this like this, right? And then we say, well, we have a shared pointer scene, and this is m.scene. And then of course it's going to complain in here that it can't create the options layer, and that is just we pass in m.testScene, right? And then in the options layer, we add another one, and this would be BVH, right? So show BVH. And then we add this, and we say, well, enable BVH view, and this would be e options show BVH. And we need to add more options. Right, so we have declared this, yeah, and then we need another option. Oh, yeah, there's going to be a slight problem. And this would be 3. Right, sure. And then we say options layer, right, and this would be BVH. No, what is it? I didn't actually, yeah. This would be view BVH, right? View BVH, and then we want something else in here. We want a slider. Yeah, because this is going to be a slight problem. Yeah, because what the kind of issue here is that we would need to pass an additional argument what the view depth should be, right? But what we could actually do is in the, I don't know how to quite hook this up. That's a good problem. I mean, you know what we could do? We could, nah, that would be problematic. I mean, we can set the option for this, but then we also need a slider for the current view depth. And what we could do is add a delegate here. This would be a sig delegates in 32t m dot view BVH delegates, right? And this would allow the application to render the thing. Although no, we could actually just hook this up to the Raytracer. The only issue is that this would need to be done at the end of the frame, but I think that's okay, because if we look in the application, GUI gets updated after, right? So it's GUI update and render, and then the window is updated. Oh, no, I don't want to call this at all anymore. Right, so I think that's okay. So we can just hook in the Raytracer, we can do this, and we can add a new function called void set draw BVH info. And this is an in32 draw depth, right? And this would be, yeah, we can just implement this, right? And then in application.cpp, we would hook this function up as well. So in the options later, yeah, we have this delegate. What would be, in this case, would be the m dot view BVH delegate, and then we would do the set BVH info and then tracer.get, right? And then in the options layer, we would have a in 32t draw m.draw depth, and this is equal by default by 0 by default, right? And then if this is the case, we would like to include an Right, sorry, I'm just thinking. Um, so then we do int 32t. So, no, we would do a I'm GUI um, float. I think we could just do a drag float, and this would be BVH view depth, and this would be yeah 1 0, and let's do like 255, right? Like let's do like 50 here. I think that would be okay. Oh, but we don't have the right. What does the drag float actually take again? Because we somewhere need to pass in the actual float, right? Oh, we need to pass in the float, so this would be m dot so this needs to be a float, and this would be m dot. No, wait. So we need a drag int, and this would be this can be just an int 32, or is this the? It is type int, okay. And then we pass in m dot draw depth, and 1 0 and layer 50, right? And this would be the address of. And then we would say in 32t draw depth is equal to m dot draw depth, and we would say m dot view BVH delegates as they move draw depth, right? And we just move that into this delegate and then just fire that way, right? So now we should see once we press the we have an error somewhere. Oh, okay, so this clearly isn't happy with it. So we might need to actually include scene here. Oh, wait a second. Yeah, no, I find out what's wrong. Oh no. Yeah, we don't actually need the delegate. Yeah, no, we don't need the delegate at all. What am I doing? Yeah, we don't need this at all. So we don't need this. Then we don't need this either. We don't need this delegate at all. We don't need this. And then the application, we don't need this either. Right. But we do need the scene in here. Right. And then we still pass in this, right? But I think we don't have this implemented, this one. So m.scene is equal to current scene, right? And does this build? Yeah, this succeeded. Okay. So then we say, well, if this is the case, then we want to say so if m.scene, right? So if this is valid, then we say, well, we don't need this either. m.scene.bvh, scene.bvh.draw. Yeah, so we do m.scene, scene.m. Didn't we have a camera? Yeah, cameras. Oh, we have a active camera. Dot get projection. Oh, we don't have the camera included in here, right? Hashtag include core/camera. Dot get projection. m.scene. Dot active camera, and it would be get view. And then we would need to pass in the draw depth, right? So now we should be able to enable this from I'm GUI. Enable BVH view. Okay, it's struggling. Let's do this not in debug, but in release. So we can hopefully get some semi-decent UI handling. Because I still need to figure out a way to get the UI running in good speed. Okay, this is doable. However, it seems that we don't have this option. So it doesn't add more to the options if the BVH is pressed. What is fine, because I think this only does it once. So we can say if radio button is equal to e options dot show BVH, then we do this, right? We draw this. Let's see if this works. So that doesn't work, okay. Interesting. But I don't like the drag float. It's too... It's not easy enough. Input int. Right, I want to be able to input it, but I think I can still drag this as well. Oh, but yeah, we... Yeah, no, right, we're gonna have to change this. So this would be... Input float would take in the int v step and step fast. Okay. Right, and I think we don't need the... Yeah, I don't think we need flags. Yeah, and I think we can do this as well, yeah. Yeah, that works. That works great actually. But this doesn't quite work. So we can check, does this ever get fired? So what is m.scene, right? Because if m.scene is still a null pointer, it's obviously not going to work. Enable BVH view. Okay. Oh, it is null. Okay. That's interesting. Wait. Oh, in here, right? In the application. Where do I make... Oh, I only make the test scene there. Okay. Right. So this needs to... Let's make the scene actually on the very top. Or like in here, right? So we first make the test scene and then we pass it in. Enable BVH view. Come on. I know the UI is horrible. It's really slow, but there we go. And now we actually have a scene. Okay. So now I should see this being drawn. There we go. That's really nice. So now I should be able to view this. All right, there we go. This is awesome. And let me take a GIF of this. Yeah, this is actually perfect. This is actually exactly what I wanted. So 13 layers in this. That seems about right. Right, so I finally got this to work. That took way longer than I wanted it, because I've been toying with this before as well, right? But yeah, no, this is exactly what we wanted it to do. yeah, this is really, really cool. Right, I'm gonna take a 2-minute break, grab some iced tea because my throat is dying again because I haven't drunk anything for a bit, and talking is really heavy on the throat. Right, I'll be right back. I'm back. What's up, guys? So there's actually something tied into what we have been doing that I want to show as well. So the right, I need to think real quick. Sorry. The option to show the BVH now that we made. Well, it shows the BVH, obviously, but it doesn't show the cost of pixels. So I want a slightly different view that calculates the cost of pixels. So I was thinking of how we could do this, right? And I was thinking we could simply do timers. And we could say, well, how long does this actually take to render? So we could just do, right, we start a timer, and at the very thing, if it's node 0, right, then yeah, I think we could actually do that. So what we can do here, we want another option in here, and this would be show pixel cost. Show pixel cost. And then we would need, obviously, in the options, we would need another thing here. So this would be const expert int view, pixel cost. And this would be equal to 1 moved 4, right? And then we go back to the options layer and we say, well, we want another radio button. And this is equal to show pixel cost. And this would be pixel cost. And then we just move that in, right? So now we have an option for that. And now if we press this, we should see an option for pixel cost. Right, oh, right, sorry, it's still the same label. So this would be enable pixel cost view. Right, and let's run this. Now it should have the correct name. There we go. And then enable pixel cost view. It doesn't do anything at the moment, but that's fine. So then what we do, we go to the Raytracer and we say the following, right? So raytracer.cpp. And then first off we say, yeah, this is return. So now we would do this at the very, very top. So if yeah, no, each thread would need its own timer, actually. Because, yeah, I don't think we can put this in here. So we can have a thread local RT timer, can we? Can we do this? No, we can't do that in here. But we can make it a global. What isn't great, but I think we might have to actually do that. So say, well, we have a thread local RT timer, right? And then we say, well, if options m.options dot and options, was it? RT rendering options. There we go. The pixel cost. Then we say, well, right, and then we say timer dot reset, because then we reset the timer, right? Because it automatically starts running once it's created. And we want to do and current depth is equal to 0, right? That's equal to 0. Because we only care about the root node. So in the root node we say, okay, bam, reset the timer. That's fine. And then we say in here, at the very end, because this is the actual... Ooh, okay. Because this is the background, right? Right, so if current depth is equal to 0 and m.options and rt.rendering options dot pixel cost, then I want another another small function called void calculate pixel cost, right? And this doesn't take any arguments. Calculate pixel cost, right? And we just put that. No, that shouldn't be in line. That should be just in the CGP. Thank you. Okay. So then we say if this is there, so then we say calculate pixel cost. Oh, but this would actually return a glmfact3 instead, right? Because we of course need to return something from here. Oh, and this function needs to be marked as const. Yeah. There we go. Very cool. And then we do the same here. And if this is the case, then we return the function here instead, right? And the pixel cost is basically the following. This gives us a concrete value. So I want to basically have a lerp between colors, right? Where you have green for very cheap pixels and red for very expensive pixels. And we can use the time as a function for this. So we'd have a float time is equal to timer. But we had a pixel. What is this called? Oh, this is just timer. So let's call this pixel timer, right? And then just put this there. And then we say pixel timer get time in milliseconds, right? And this should give us a... Let's just put a printf here, right? Printf %f /n and then pixel timer, or sorry, time. Okay, so then if I press the render, we should see an explosion of pixel times in the console. Oh yeah, I do. Ooh, okay, but it seems to be keep adding to the timer. What's odd? Oh, and then we need to... No, because that should be fine. Anyway, we can figure this out later, right? So then we have the time in milliseconds. Yeah. So does reset timer actually does what it should? Yeah, it does. Okay. I think we could just try a Gilam lerp and see what happens. So decalculate pixel cost, right? So we then want to do a return GLM lerp. And I think it's... Oh no, that's between quaternions. I think there is a lerp, right? I'm pretty sure GLM has a lerp for vectors. Oh, maybe it's smooth step. Yeah, I think it's step. Right, return 0 dot effect. Yeah, yeah. No, that isn't quite it either. Yeah, I think you can just do lerps like this. Okay, sure. So it would be glm lerp, glm vec3, 1 dot, no, sorry, 0 dot f, 1 dot rg, yeah. And then another glm vec3. glm vec3, and this would be 1 dot f, 0 dot f, 0 dot f, and then this would be time, right? Oh. And then this needs to be removed as well. Okay. But we should be able to call lerp like this. Or does glm lerp only works with... I'm pretty sure we can use glm. Okay. Right, so apparently it's not that easy. We kind of need to combine them, because I think the glm worked with a single value, right? Okay. Yeah, we need to combine them in one value. Okay. I mean, what we could just do is this would be RGB. Okay, so this would be 255. I think that we can do smooth step. I think we can do 255. Let's say like 1,000, right? Does that work? Do they need to be floats? No. Because I'm pretty sure there is some kind of lerp. How did I do this? Because I'm pretty sure we have this. Right, okay, so we need a helper value here. I think we could just put this in here, actually. No, we can't, okay. But we can put it here. Okay, and then we say the following, right? So the colors are like this, okay. So then we say, well, we have a int red, and that's equal to, oh, so it would interpolate. So int result is equal to interpolate, and then we need hex code for red. What is this? I think we could do OX FF 0000, right? Then we do OX OO FF 00, right? And then we say fraction is equal to time, right? And then we get a result. And we say int R is equal to result 16, because we need to shift that out, and then at okay, no, we need to do this RGB, right? So now got these, and we can remove the duplicates, right? So this would be RGB, and this would be result, right? And then we would say return, and that would be R divided by 255 dot F, G divided by 255 dot F, and B divided by 255, right? Like this, right? So what kind of values are we getting here? Because I have no clue what kind of timer result we're getting. Right, and then enable pixel cost view, right? Oh, and we're doing it lerping in the wrong way, but that's fine. Let's actually just see what this does. So this isn't quite correct, okay. Because we're still seeing the objects here. What's interesting? Oh, no, I don't want to close this, right? So we have this, right? Yeah, so this fires, but does this fire? No, wait, this never fires. Huh? Oh, but we still have this function fires, right? Yeah, oh, but there's always, yeah, because there's no refraction. Okay. And this is false. No, wait, we don't want to do that. So yeah, I think we just want this as well in here. Okay. So I think we yeah, I think we need that in there as well. Because that was just putting the reflective and diffuse color as well. Right, enable pixel cost, right? Yes, oh, this is actually working really, really well. Because we can clearly see that like these are more expensive, right? But we want to switch it around. So we want to say this is equal to 00 FF, and this is equal to FF00, right? These are just hex codes. And then we want to run it in release. And then we kind of want, I think, another slider in here. Okay, no, that's cool. We can clearly see that this is darker. And we can see some pixels that are very, very expensive to calculate. Huh, okay, that's really, really cool. So let's say I turn on reflections. So we say, well, it's already reflective. They're clearly not reflective. I call bullshit. Yeah, they're not reflective at all. Let's move the camera a bit closer so we can actually get a bit more. Ideally, we would add a kind of slider that would change our sensitivity to this as well. Yeah, I don't think they're reflective at all. Wait, what? Interesting. So why is the reflectiveness not working? That should still work, right? Oh, no, it doesn't. Because it's now based on only refraction. Okay. Right, I think we still need to do reflection, though. Okay. Yeah, because this would... Yeah, I know I see a small problem. Because this goes... this assumes that... Yeah, because we now can't just do only reflections. Because it would only do refractions now. Okay, but that's okay. What we could do is we can say, well, we go to application and then we say it's now refractive. Sure. Okay, that's pretty cool. So now if we do the pixel cost view, it's still very, very green. So just to be sure, did I put this in correctly? Yeah, so what kind of value for the... Yeah, I'm just guessing this would be just too small. So we can just say, what if we do it times $10, right? Just to increase the sensitivity a bit. And then we say enable pixel cost. Oh, there we go. That's actually perfect. No, this is really cool. So this is the actual cost of the pixels. So we definitely need a way to set these values a bit better. Yeah. Because this doesn't allow for any tweaking whatsoever in the values. But this is really cool. So we can see that some pixels of these are still very cheap to calculate, like some part of these transmissions. But this center part is really expensive. That's really, really cool. So if we just do, say the application, right? We turn the number of cars down and we go to like say 30, only 30. That should give us like a much less heavy view, right? Yeah, so now you can see some parts are more expensive than others. But we really would like some way to modify this. So instead of just simply having Raytracer.h, right, it has this options. So we can go to options layer, no, sorry, rendering options, and we do a struct options. And this would be a int option. So this would be state. No, we can just call this. Yeah, we can just call this mode. Int mode. Float. Pixel cost. We can just do this, set this equal to no effects, right? And this is equal to 1.f, the sensitivity. Pixel cost sensitivity, right? And then instead of an integer here in the option layer, what we say, well, I want yeah, no, we would need to include, no, we already have that, right? So we would say we don't have an int option, we have a options option, and this is just default constructed, right? Oh, and this would be yeah, right, I see. And it would be option dot mode. And then just need to replace all of this. Okay. And then obviously, I think we still need the rendering options in the header actually. Because otherwise the delegate is going to complain. And this would be, instead of an int32t, this would be RT rendering options dot options. And then in the Raytracer, we need to change this as well. So this needs to include, I think, graphics. No, I mean, might be under core. Core slash rendering options, right? And this would be, set options would be RT rendering options. And then we would have this as the type as well for the options. And then it's going to complain in a bunch of places. Because this would be, yeah. Set options is going to be wrong as well. No. So why is it still complaining? Right, we had the another set options that we can remove. Yeah, I don't know why this is complaining, but whatever. Wait, why is this ambiguous? Huh? Right. And then we need to replace this by just doing dot mode. And we say dot mode, dot mode, dot mode. Oh. Why, how is this ambiguous? Option layer. Let's call this just option struct then. Or options data. And then just change that in a bunch of places. And then this would be options data, application CPP. I don't think we have to change anything there. No. Raytracer.h. should be rend options data, options data, options data. How is that ambiguous? We're including this rendering options thing. What is just destruct? Oh, I never break my ones. Right. I think we got rid of. I think they should compile. Yeah. Those should be options, right? And then in here we can simply say, in the sensitivity, and then instead of here we have we can just do options, m.options dot pixel cost sensitivity, right? And then in the options layer, we can say if no, I think we don't. Yeah, we don't have to do this here actually. No, we only have to do this at the very end. Yeah. So we just do this in here. We actually do the delegates. We send the delegate off, right? Because we can only do this once a frame anyway. Right, and then we do if this is e option dot show pixel cost, then we so so be a flow drag float. Yeah, and this would be option dot pixel cost sensitivity, right? No, we actually do want to store this in here. So this would be float m dot pixel cost sensitivity. That's equal to 1.f. And yeah, whatever. And we could just say, well, we pass in actually this. And this would be drag float. V speed would sure be 1. This would be 0. And this would be 100.f. Sure. This would be 1. And this would be 1,000.f. Sure. And then we say, we don't do this. We say options dot pixel cost sensitivity equals to m dot sensitivity, right? And then we move that, right? So now if we press the pixel cost button, we should be able to get a slider that, there we go. Huh. Oh, wait a second. Yeah, no, I see why I did this option delegate like this. Because that was not working. You know what we could just do? We could just do a int current mode, right? And instead we say current mode, this would be equal to 0. And this would be no, cancel. This would be m dot current mode, right? And this would be m dot current mode. And we do this, 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 right? And we say options option dot mode is equal to current m dot current mode. Right, and then this should be fine. Yeah, it would only fire the delegates quite often, but that's okay. Yeah, no, I think that's fine. Yeah, there we go. So now we can tweak the cost of this, right? And we can, if we drag this up quite high, can we do like 2000 by hand? Yeah, I think we can. Yeah, so we can tweak this by hand. So we can actually see that if we put this way up, we can see that the costs around the cars become darker as well, right? So we can actually see the cost of the BVH, where the deeper we go, the more expensive this is. This is really cool, actually. And it's kind of grainy, what is cool. Well, it makes sense, right? Because we're using kind of an abstract measure to do this, but it's time. And time isn't going to be perfectly accurate because our processor can have other things being done and stuff like that, right? So this is a decent estimate, I think. And we can see that if it's like set to like 1, right, it's kind of hard to discern, but we can tweak it to get a more accurate like view. I think it's really cool. And you can see hotspots better like this. So I think that's actually really, really awesome. Yeah, no, I think this is... Oh, and we need to rename this, actually. So this would be uh, pixel cost sensitivity. Yeah, that's definitely wrong, spelled wrong. Sensitivity. There we go. And that should be all. Should be perfect, actually. That's, I think, really all we need. Come on. Oh, why didn't it accept the run? Yeah, no, I think this is really cool. So the only thing I could think we can improve on is by showing more information, or have an option to show the model BVHs. Wait a second. Is this correct? I think it is. It might just be my perspective camera messing up a bit. It might be slightly off, actually, looking at it. Huh, it's definitely doing some interesting stuff. Oh well. It should be okay. It might actually be fine. But this, I think this is the coolest feature of all so far. Because now we can actually visually see what pixels are expensive to calculate. But obviously, we can see if we turn this up, right? The sky is dirt cheap. This is pretty cheap. But the deeper we go into the scene, the more expensive it becomes. Where these are actually pretty expensive. This box. Same with, like, this box is really, really expensive. What I think is cool. And we can tweak it as well, right? Because the issue is we're using time as a measurement. So if the scene runs faster, it means that the sensitivity will become... we need to increase the sensitivity. If the scene is really slow, we might need to decrease sensitivity. What's kind of an important thing. Because it's relative. We can't really put an exact measure with using time for the cost of a pixel. Because things change all the time, right? Because it depends on the frame rate. And we can't really multiply by delta time either. I mean, we might help, but whatever. Doesn't really matter that much. So one thing I was actually curious about is in the scene BVH, we can say, oh no, the scene BVH is that, but the regular BVH, we're only using 16 splits. But what if I go up to say 64? And in the header, we would need to change the serialization header here as well. So in the header, we also do the following. We say uint32t num of splits, right? And this would be version 2 now, actually, of the header. And in serialization, we would say file header dot number of, oh, this slits, no, just be splits, of splits is equal to num of splits, right? And we could say, we could check here in the read PVH. So if the version is out of date, or header check dot num of splits does not equal num of splits, we say, oh nope, this file is wrong. So I think if we rerun this now, I can see in the console that it should be rebuilding. Hopefully. Yeah, there we go. It's now rebuilding. That's really awesome. So what changed, right? Like visually nothing changed, but we're using a higher quality. Oh, my game crashed. We're using a higher quality BVH now to calculate the cars. So that should, in theory, speed up our performance. Huh. Why is it doing this again? The BVH construction. That's weird. Wait a second, okay. But is reading the header, but then it returns false, right? And it should serialize it again. Yeah, and here we set the number of splits. Huh. That's weird. So let's debug this, right? So it should say, let's just put a breakpoint in the read BVH. Okay. So say, well, the red version is 2, and it's 2, right? And number of splits here is 0. Okay. So then we return false, right? And then it says, well, yada yada yada. Yeah. Oh, we read the BVH, no, so we build the BVH and we serialize it. I think that's building it, yeah. And then we go to serialize. And now I need to wait for it to be done, of course. That's going to take a while in debug. Okay, that's actually really taking debug the higher quality BVH. Holy. Okay, it's done. Okay, cool. So then we serialize it, and then we go to get file name. I don't care about that. Serialize, no, get base tier, not important, serialize. Right, and then we say file header is equal, yeah, number of splits is 64, right? Could it be that it just adds it to the file? I think it might be. I think it just keeps adding. Let me actually check how big this this BVH file has become, and we can verify this by putting it on release and then just rerunning it. Current tracer, assets, potato, no. Would be Ferrari dot. Right, so it's 6.6 KB. So if you rerun it, does it become bigger? Oops. Builds it, yada yada yada. Then yeah. Why is it computing breakpoints? Oh yeah, it keeps increasing in size. Huh. So if I run this again, it's now 12 KB. Right. So we need to yeah. So now I think it's increasing in size again. Yeah, it keeps increasing in size, okay. I think it's now wait, why are there multiple Ferrari WVHs? So it's now 12 KB, so 12 point something, and then I run it again. Yeah, I think we could fix this. Yeah, so it was 12 point something, 12.468. Yeah, I think it rebuilt it again. Okay. Right, I think we can do right. We need a different type. So in the serialize, right, we need the BVH.cpp. I think we can do no, that's read, but in here we do read write back write plus binary, I think. Come on, where did I put the read serialize, right? I think there is the way plus, so yeah. Yeah, no, this should be okay. Because if the file doesn't exist, right? So if I just delete the Ferrari.pvh, right? It creates it once now. Okay, let's see what this does. So it creates the BVH, cool. It creates the file. We close it. And this is 12.468, right? And then if I run it again, does it create the BVH again? It does. Okay, so there's definitely something going wrong. Like there's actually something weird going on. Is what we do simply here, right? Is we say, well, the file header dot number of splits is equals to this this predefined header, right? And then in the read BVH, oh wait a second, yeah, no, I know what's wrong. It's not that it isn't working. We check this is the red header, right? The header check is yeah, no, I see what we did wrong. We have two headers. One is the check that's comparing. Yeah, now it just loads it in. Fine, no problem. Okay. But the reason I was doing this is now I can increase the number of cars and see if a higher quality BVH makes like any massive difference. I doubt it, but it would be a good test, right? No, I don't think it makes a big difference, but I mean, it might be a bit better, but I don't think it's very drastically better or worse. Because it's just going to change the internal BVH by a bit, right? And 16 is already reasonably accurate, right? So I think this should be okay. And I can see in the console here as well that the BVH construction times are about 7-8 milliseconds, and the rendering time is about 500. So that means that the BVH construction time is almost irrelevant to the time it takes for the scene to render. So I think we can accept that. So one more thing I do like to put here in the stats window is actually how many triangles we're rendering. So in the, I think we have this stats layer, right? Stats layer. Yeah. I think that, yeah, just takes the delta time. But what we could do as well, we could change it to pass in the scene as well, but I don't know if I like that very much. I think it might be good to pass in the scene in the AmGUI layers as well. So we can change the signature, right? We can say, well, I want to refactor change signature. And then, oh, you can't see the resharper window, that's a shame. Let me just do this real quick so you guys can see it. Right. Right, there we go. And now it's been changed. And we do need to include scene, right? So we do core / scene.h. So now any AmGUI layer knows about the scenes. Right? And I think in... Okay, now, yeah, there we go. We have this in the update. So in the application, we can say... in here, we would say m.test scene. Right, why does this not... Oh, right, this would need to take a scene as well. Okay. So take an SD shared pointer of scene. Yeah, include core.scene. This would be current scene, right? And then we say current scene. And then application.cpp, we pass in test scene, right? There we go. And then this should run. All right, okay, so this is working. So now I think in the stats layer, we can do the following, right? We can put, we could go do for and then say current scene dot models dot size, and we would do a uint64t, and this would be triangles, right? And this would be equal to 0, and it would say, well, triangles plus equal current scene dot models dot y dot triangles dot model data dot triangles dot size, right? And then we would do a AmGUI dot text yesterday to string triangles dot cstring. You know, I think this is just fine. But then we do want a other string, so this would be std string num of triangles. string. Right? And this would be equal to number of triangles, and then num of triangles plus equals std to yeah, that would be this part. Right, and then num of triangles plus equals slash n. And then we say num of triangles dot cstring. And now we should see another small text thing that shows me the number of triangles I'm rendering. There we go. That seems to be very, very high though. So that would be, let's see if we can add dots there. We should be probably be able to. Okay, that isn't really that useful. Yeah. Okay, I think it's possible. I think we can throw a small helper function here. And we need to include string stream. String. I don't know. No, I think this is fine. Wait, I need to find std string stream. I think there is a, what header is it? Oh, ss stream, okay. Right, okay. There we go, and that would be t value, okay. So we'd pass commas, and that would be number of triangles, right? Okay, let's see what this does. Because I hope this puts some commas in. No. Okay. I was hoping that would work. Why does that not work? Oh, whoops, this would be, sorry, this would be triangles. Yeah, no wonder I don't pass a number in. Obviously, it's not going to do anything. Yeah, that was a derp. There we go. Now it puts dots in. However, it still adds a space, but yeah, I think that's acceptable. Yeah, sure. I can deal with that. At least now it's a bit more readable what the actual values are. So this would be rendering 46,936,000 triangles, right? No, I think that's clear. I think that's a nice addition. It just adds some extra information, right? But it is. It seems that this is about all the time I have for today, because I have to work in a little bit. So I have to prepare for work, make some dinner, and I will see you all later. Everybody that joined in for the stream, thank you very much, and I hope you had a good time. And I will see you all later. Thank you for watching the stream, and have a good day.